Good morning, good afternoon, good evening, everyone. So thank you for joining the Around the Clock with Azure SQL Data Factory and the Azure SQL Database. Now we have a new session in terms of the pattern and the back practice of using Azure Data Factory for data ingestion. So let's get started. So basically, when we're talking about the data ingestion using Azure Data Factory when you modernize your data warehouse, we are talking about this blue, the red triangle in this chart. So you are normally using the Azure Data Factory to move the data from big variety of sources into data lake for further analysis. This is we call the process. When you move the data, we call data ingestion. So we're gonna go through two major use cases in the data ingestion scenario. The first data case is you already have the existing on-prem data lake or data warehouse in your environment. You want to migrate this kind of data warehouse or data lake into Azure to modernize your data warehouse on cloud for any kind of data analysis. This is the first scenario. The second scenario, the second use case we're going to talk about is you may or may not have existing data lake or data warehouse, but anyway, you need to ingest data from big variety of different sources like your operational database, your sensor device, or your any website from big variety of sources into data lake, and then do further analysis. So in this section, we're gonna describe some pattern and best practice of how to use ADF in a most efficient way to handle this kind of two use cases on data ingestion. So for the first use case, as I just mentioned, you may want to migrate your existing data on your data lake or data warehouse into Azure. Your existing data lake or data warehouse can be Amazon S3 or on-prem Hadoop cluster or Oracle server, Metadata, Teradata, Redshift, any kind of this data sources is the major type of your data existing data lake or data warehouse, right? So you may want to using a data factory to move this kind of data from this place to Azure. So if that is the use case, here I list two concrete examples from real customer how ADF can help them to move the PB level or thousand of terabyte data level of the data into Azure. So the first use case is from one of the customer example. This customer want to migrate two PB data from Amazon S3 to Blob. So the requirement from this customer cases is the highest priority from this customer is say they want the performance, the best performance as fast as possible to move the data. So this is the top priority requirement from these cases. And the second requirement from these cases is giving the migration itself, the migration for data lake or data warehouse is a kind of big project. Normally it's gonna last for several weeks or even months, right? So and the data migration is only part of the entire migration flow. So after you migrate the data, you may also need to migrate the application from your on-premise, data lake to Azure, right? So given that, so after you first migrate all the historical data from your existing data lake, you may also need to incrementally migrate the changes every day or every few hours into the Azure as well to make sure during your application migration step, so your application can always consume the latest data which have already migrated to Azure. So they need a historical data migration plus incremental feed. And the last requirement from the customer case is they want a tool with a very cost-effective way. So it means they only want to pay for the real, the real usage for them to use the tool. If ADF is used to move the data, yeah, they're gonna pay for ADF. When they stop the job, they do not want to pay anything. So this is what they want. So you can form the result. You can see ADF have been perfectly meet all the kind of requirement. So after this customer successfully migrate 2 PB data from S3 to Azure Blob, you can see the initial historical data migration. ADF have reached more than 2 gigabytes per second throughput. So it's also saying ADF is fully 100% utilize all the network and storage bandwidth. From ADF side, we can even further enhance our copy job engine to even increase the throughput, but giving the limit of the network bandwidth or the storage or source destination different the latency bandwidth. So this is the best the case for this particular customer environment. And also ADF only costs the money when the engine be allocated and start to copy the data, and it's running in serverless mode. We call pay-as-you-go mode, right? Okay, this is the first case for the migration from Amazon S3 to Azure. And the second concrete customer use case is the customer try to migrate their on-premise the data warehouse to Azure. The total volume of data want to migrate is about 25 terabytes. So the requirement from this customer case is slightly different from the first one. They actually do not care much about performance. They do want to have a very flexible plan, migration plan. Something like they only want to migrate the data outside of the office hour, right? So they only afford to do this kind of job when people go home, or the data server or data server is not that busy. So they even do not know when it's the server can be free, but as long as it's free, they can start the job. And when the data server or the existing data warehouse have the load, they want to pause the job until next time they have a time slot to migrate data. So they care a lot about the load impact on the existing server. They do not want the migration job impact anything on the existing server. So they only allow up to 8 concurrent connection to the existing data warehouse to avoid impact the existing load. So ADF can also fully support all these kind of requirements. So this is also the output. And finally, so the customer successfully migrate all the data from the Metadata to ADF on Azure in 3 weeks. So here, one of the pattern so I want to share is from both of the concrete customer cases I just shared, both of them using the metadata-driven pipeline for the data migration. So let me double click a little bit on the metadata-driven pipeline. So when you try to move or copy a few table or few folder account from source to destination, the best way for you to achieve in ADF is you can create copy activity or 1 or 2 or several copy activity in a pipeline, right? And then you trigger your pipeline to move the data down. Everything working fine. But when you try to move thousands or 10,000 of tables, or you're actually moving like PB level data from existing data lake, which means it can be coming from different type of storage, right? The multiple server. So if that's the case, it's you're gonna facing an issue. Say, hey, it's hard for me to input 1,000 table name into ADF, so and trigger the job, right? Then given that, the best practice is you should create a kind of we call parameterized pipeline. So create a a set of parameter in the pipeline where the real parameter value, you can write a query to write the real parameter value into a table we call control table. Here's the example here, right? In your control table, it can have column something like server name, a DB name, a schema name, or the watermark, the value or any batch ID, whatever. It's you can define everything in your control table, and then after that, you can create a parameterized pipeline, like the example here. The pipeline gonna start from a lookup activity. This activity gonna try every time before the pipeline run, it's gonna enumerate the real value, the parameter value from your control table. And then after get all the kind of parameter value, they're gonna distribute the real value to the downstream application. Like this example, it's a main pipeline may look up the DB list here and execute another pipeline, and for each of the database, right? And the downstream pipeline for each of the database, it's gonna look up the table list and then execute the third pipeline. And the third pipeline, the real, the pipeline who do the job for copy a single table, something like those. So giving by design the pipeline like this, so you actually control the pipeline copying job behavior by update or create the parameter in your control table. You even do not need to care, hey, what the pipeline look like or how I change or redeploy the pipeline. You only need to update the value in your control table. Then the pipeline can automatically adjust the copy behavior based on your parameter input in your control table. So this is how the concept of the metadata-driven pipeline, right? So let's go back to the data migration scenario to how we map the metadata-driven pipeline pattern into a data migration scenario, right? When we move a huge amount of data from your existing data lake or data warehouse to Azure, so we strongly suggest you do a POC against some sample data in your environment. So before you really create a pipeline and directly migrate data in production. The reason is, your file pattern, your network bandwidth, or everything around your environment is unknown, right? So you need to, based on some of the POC testing, you can gradually figure out and resolve the performance bottleneck. For example, you may start from copy 10 of gigabyte data first by a single copy activity, and from after you copy the data, from the copy activity monitoring page, it's going to show you some performance tip to tell you, hey, what's the performance bottleneck from your last run. It can be some bottleneck from the source store or destination store or network, or even maybe for ADF itself, right? And then given that, you can change some setting in your environment and do test again. So until you can gradually, change something to the test and change again to make sure you are using the copy activity in the most efficient way. And after that, you can, at the same time, actually, you understand your data structure by this kind of testing. You can know, hey, the data I'm copying is huge amount of small file, or it's just a few big file. So the two different data patterns gonna result in total different, how you want to copy the data, right? So if you are copying huge amount of small data, the partition is strongly suggested. So you're gonna partition your file and let each of the copy activity copy one partition at a time. This is the recommended way. But if you are copying a few very big file, yeah, it's fine. Single copy activity can handle everything. So, and also the third purpose for the POC is you can get estimate time required for the entire data migration. For example, you say, hey, copy 100 gigabyte file require, for example, 10 or 20 minutes. And then now I'm facing to the problem to copy one PB file. then I can estimate the time required for the migration project, right? And after you understand everything by a POC, and then you can really create a pipeline in production by metadata-driven solution. So you can create a control table, and in each row, you can define one partition for one row. And how to define the partition is based on your POC testing on your sample data, right? So, and you're gonna, based on the POC, you're gonna know, okay, for single copy activity, how long it need to take to complete copy the single partition, right? And based on that, you can also, list all the partition in a control table. As well, you can add one additional column, say the batch ID. So say in the first batch, I only want to copy 10 partition. In the second batch, I want to copy 20 partition, something like that, so that it can meet your requirements for the flexibility to pause your data migration job, and you start it again when some time slot allowed. So yeah. So and all what I talk about have already been published as a ADF template here. So here you can see if it's in your Data Factory UI, you can see something like migrate historical data from Amazon S3 to Azure Lake Gen 2. So all the kind of experience have already been published as a ADF template. You can start from that. And then from documentation, you can also see the similar thing here. Okay. And so the next use cases I'm going to describe is how to inject data from big variety of sources into the Azure for further analysis, right? The reason ADF is very optimized for that use cases is we have, ADF have more than 90 built-in connector for you to use. So you can easily get access to huge amount of different data store and capture the data from there into Azure, right? And no matter the data was on-premise, it was on cloud, and given we assume for this kind of a data ingestion job, so the pipeline should be running almost forever, right? You're gonna create a pipeline and configure the schedule, say I want to ingest data every day or every few hours, and then you just let it running when the time is up, right? You will not you do not want to care after the pipeline was running in production. So given that case, ADF also have a very well integration story with Azure monitoring, so you can get a alert mechanism. So if anything fails, it's gonna send a mail to you, and you can double click to see what happened. Otherwise, you do not need to care about that. And also, given if you have a huge amount of project ongoing, you're gonna gradually get many different pipeline factory. So we have a very good CI/CD scenario to help you to improve the develop productivity. Here I want to share a little bit about the best practice for this use case, how to use ADF. So the biggest problem I can see in this use case is the user keeping at how I can use ADF to incrementally get the changes from source, right? So given it's ongoing data ingestion use cases, so every day I only want to capture the data changes from yesterday, or I only want to get the new file arriving on some source store, right? I do not want to every day repeatedly capture all the data. So here I list the 4 different patterns of the how to use ADF to incrementally get the changes. The first one is, in today's copy activity in ADF, we support move binary file from storage to another storage, which say if you check the box like this, every time when ADF moves the file from a sort to destination, the copy activity is gonna automatically delete the file from sort store, which have already copied to destination. So this is one the feature which should be helpful. And the second one is ADF support to easily copy data from datetime partition folder. So when you define your folder, something like year, month, date, or this kind of, or the file name have year, month, date as a prefix. So you can define a kind of wildcard or using system parameter in the pipeline to achieve the case that every day ADF only get the file in that day or only get the file in that folder. The third one is ADF can support the saying like we only copy the data based on the last modified date after several days, right? But please be careful when you use this feature because it's require ADF as a client side to always enumerate all the metadata from your source store and then compare the last modified date property with the system trigger date, right? And then to filter out, okay, this is a set of file required to be copied. So if you have a huge or million or amount of file on the source, it might hurt a little bit on your copy throughput, the performance. You're gonna say, you're gonna be aware, say, hey, a huge amount of time happened on enumerating file, even before the copy. So given that case, we're gonna suggest you to do a kind of regular cleanup on your source. So do not leave the huge amount of file on your source store. And the last one is ADF copy activity also support a feature say, give me the file list, and the file list can be writing into a CSV file, and within the CSV file, just give me the folder path and the file name. That's it. No matter how you capture the change file or whatever the file you want to copy, just input all the file path and the file name into a CSV file, and let ADF know where to catch that kind of file, and ADF just copy everything for you. So given that, you can do a kind of customized way to do your own incremental pattern to capture the change data and input the file name which you want to copy into this kind of list of file, the CSV file. Okay, so this is the last page. I want to share a similar thing, how to get changes from the table when you're using ADF to move the changes to Azure, right? Again, so there are several different patterns. The first one we called it, if you have the timestamp column in your database. So yeah, so then you can using a terminal window trigger plus some dynamic query like this. So basically it's gonna automatically help you to generate a kind of query against the trigger time. So, and then the query is gonna be applied to your source to identify the changes and then copy the change row only. But if you are saying, hey, my incremental, the logic for my case to identify the changes is not belong to, or it's not specified by the trigger time, right? The current job trigger time. It's actually by some ID, increasing ID, or some saying some timestamp may not be current time, might be something like 10 days before, something like that. Then you can go to the second bullet, which you can, we call the watermark solution. You can compose two lookup activity. One is to query the old watermark. The second one is to query a new watermark. You can put the watermark value and the column into one control table, similar as a metadata-driven pipeline, right? And every time the ADF pipeline can look up your watermark from your control table and then grab the gap between two marks and then pass it to the copy activity. The copy activity can only copy the delta, And after the copy complete, it will trigger another, you can define the store procedure to update the latest version to your latest version of the watermark value to your control table. You can achieve in that way. And we also see in many cases, so the user say, I just want to copy a small table. So in that case, the suggested way is you just every time you repeatedly copy the entire table every time. So rather than achieve some complex query like this, because the table is small, and you can just do full copy and overwrite. It's very useful for the cases when you want to copy the dimension table. And the last one is, when for many cases you can compose a query to query against some thing called a change tracking column, or similar to the change tracking feature in Azure SQL DB. You can compose a similar query against the system column to identify the changes. Okay, so this is the typical incremental data pattern I want to share to the how to get changes from the tabular database. So as a summary, in this session, we come up with two major use cases of data ingestion, with the first one, data migration. And the second one is ongoing data ingestion. For data migration, we share some best practice of using metadata-driven pipeline to do the data migration, especially when you want to migrate PB data, or the huge amount of table, something like that. And the small POC against the sample data to identify the problem bottleneck is strongly suggested. The second scenario is to illustrate some pattern or best practice for ongoing data ingestion for the data analysis. So we provide 8 total to how to use ADF to get changes data from both Firebase store and tabular database. Okay, so that's it. So be happy. I'm very happy to share the experience. Hope it helped. And if any question, feel free to send a mail or this question to us. And thank you for your time to join the session. And have a good day and have a good evening. Thank you. Bye-bye.